Good morning, guys. We are still working our way through the geometry chapter. We are almost done. We have a few more lessons to go. So today's lesson is on polygons. A lot of this stuff should be familiar to you guys. And then we are also talking about tessellations. You do have a project tomorrow that is on tessellations. So the last couple of slides are on tessellations and examples of them and a question that you will see on your homework today. So looking at polygons, just a quick definition of a polygon is a simple and closed figure formed by 3 or more straight line segments. So a simple figure is one that does not have lines that cross each other. A closed figure means that it's like it is closed. So looking at this, these are just some examples of what a polygon can be. So if you look to these examples right here of polygons, sorry guys, of polygons, you can see some examples of them. There's pentagons, they're shaped with 3 sides, 4 sides, 8 sides. We will get into all of those in a second. And then the non-examples of polygons, anything with a circle in it is not a polygon. A straight line, this rectangle right here that's yellow is not a polygon, because if you can see the line on it right here, and right here stops, so it's not connected, so it would not be a polygon. And then we have been talking about classifying polygons as far as, or we've talked about classifying other shapes. So now we're going to talk about classifying polygons as well. So you classify polygons based on the number of sides that they have. So looking at this slide, these are just some examples. These are the normal ones. There are different examples. So if it doesn't look like this, but it still has 6 sides and it's just a closed shape, it can still be a hexagon. If it has 10 sides to it that are straight lines and it's all connected, it can still be a decagon. So we are going to talk about this and go through several examples. So the other important keyword that you guys need to know is what a regular polygon is. So a regular polygon is a shape that has all sides that are congruent and has all angles that are congruent. So remember, congruent is that they are the same. So an equilateral triangle and a square are all the same. This type of hexagon is a regular polygon. The octagon is a regular polygon. So as long as all the sides are equal and the angles are equal, then it's going to be a regular polygon. So on some of the questions you guys have, it'll ask you to classify the polygon as far as what shape it is, and then also tell if it's a regular polygon or not. So looking at that first example, this first one is 1, 2, 3, 4, 5, 6 sides. So if you look at your little chart, I believe your homework, your homework gives you an example of it. So you have that in front of you. So it has 6 sides that are all even or equal to one another. So this would be a hexagon. A hexagon has 6 sides. And then you need to determine if it is regular or not. So on this, all of the sides are equal. With the sides being equal, the angles are going to be equal as well. So this would be a regular hexagon. And then on this side over here, this has a circle shape to it. It doesn't, it has 1 side. So this is not a polygon, okay? That's all you have to write. Please don't leave it blank because it may look like you just didn't do it. So at least write not a polygon, or this figure is not a polygon. It's neither, just whatever tells me that you actually answered the question instead of just skipping it. So looking at this, this is then finding angle measures of polygons. So this shape is giving you a pentagon. It has 5 sides. So you are going to find the measure of each angle of a regular polygon. So because it tells me that it's regular, that tells me that all sides are equal and all of the angles are equal. So the easiest way to do this is to make this shape into triangles. So I am going to pretend that that line ends right there. I'm going to make the shape into different triangles because I know how to find the angles or the degrees of a triangle. So now that I did that, if you look, I have, this is one triangle, this is a second triangle, and then this is a third triangle. So I know they all look a little bit different. This is a right triangle. This is just a triangle. This is an obtuse triangle. This one would be acute. So I have 3 triangles that are formed, and then I'm going to find the sum of the angle measures. So whenever we were doing a triangle, if you remember correctly, a triangle needs to add up to 180 degrees. So this triangle would have 180, this would have 180, and this would have 180. So the way that I can find that is by multiplying 180 times 3 or adding it together 3 times, whichever. So 0 times 3 is 0, 8 times 3 is 24, and then 3 times 1 is 3, plus 3 is going to give me 6. I was wondering what I did wrong. That was not adding up correctly. Sorry, guys. This is 24, and I wrote a 3 up top, so it should be 25. Teachers make some mistakes too. All right, so this is 540. So I have 540 degrees that is my total angle measure. And then I have 5 angles, so 1, 2, 3, 4, 5, because it's a pentagon. So I'm going to take 540 and divide it by the 5 angles, and then I get 5 goes into 5 one time, and then I'm just going to look at this, and I know that 5 goes into 4 0 times, and then 5 is going to go into 48 times. So each one of these angles is going to be 108 degrees. We're going to do one more like this with an example of an octagon. So same thing, I'm going to go ahead and make some triangles. So I'm going to first draw a line across. Let's connect right there. Connect right there. Connect right there. We'll connect more in the middle on this one. So hypothetically, you should have 8 triangles. So if I have 8 triangles and each one adds up to 180 degrees, I would then have 180 times 8. 8 times 0 is 0. 8 times 8 is 64. 8 times 1 is 8. Plus 6 is going to give me 14. So I have 1,440 degrees that this whole thing is going to add up to. And then this shape has 1, 2, 3, 4, 5, 6, 7, 8 sides because it's an octagon. So I'm going to divide this by 8. And then because you just multiply it, you kind of know what your answer is already. So Then looking at tessellations really quick. Tessellations are a repetitive pattern of polygons that fit together with no overlaps or holes. So as you can see, these are examples of polygons. So this one has some squares, some triangles, and then some hexagons. This has hexagons and triangles in it. This has a square or a kite. It has 4 sides, and then this shape has 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So this is where the shapes don't necessarily have to look like they did on the first slide. So then a tessellation example. Miss Evans wants to design a floor tile using pentagons. Can Miss Evans make a tessellation using a pentagon? So the measure of each of these angles in this pentagon and the angle is given to you in your book. This is one of the examples from your book. So it tells you that it's 108, but I need where my vertices meet in my tessellation to be 360 because that's a complete circle or a complete angle of where all the sides are going to meet. So to figure this out, I'm going to take 360, which is what it needs to be for all of the shapes to meet completely, and divide it by 108. And I wrote 180 right here, but it should be by 108. When you divide those two things, you get 3.3. And because that answer is not a whole number and it doesn't add up to 360, she cannot make a tessellation with a pentagon. So up here, I tried to show you guys what would happen if you did make this a tessellation. So these two shapes fit together really well, but if I were to put another pentagon, and I know this isn't perfectly lined up, but if I were to put another pentagon, there would be a gap right here, and another pentagon would not be able to fit right there. So for that reason, you cannot make a pentagon or make a tessellation with just pentagons. She could do a tessellation with pentagons and maybe add some triangles in to close those shapes, but just with pentagons, she would not be able to make a pattern because it doesn't add up, but it also doesn't fit when you draw the shape or mess around with the shape. So you guys will be working with tessellations tomorrow and Friday and kind of making your own. So if you guys have questions about shapes, please let me know. I know some of this can be a little bit more difficult. So make sure you're answering the questions completely, that you're saying what shape it is, but also if it is regular or not. I hope you guys have a great day. If you have questions, please let me know.